Okay, so what we're going to do is we're going to talk about a couple things, chain rule, and that can also affect more. So I'm going to talk about derivative all the trig function first. D to the dx of sine of x and d to the dx of tangent of x and d to the dx of secant of x. This one's negative. This one not negative, sorry. It's going to be cosine of x. This one's secant square of x. This one is going to be secant x tan of x. This is usually one I remember. Okay? And Logan remember by heart now. I don't know why, but so if I want to take a derivative of any of the co-functions, which is cosines of x, of cotan of x, you see that equivalent tangent and cotangent, and d to the dx of CSC of x, that's equal to cosine of x, that's equal to negative sine of x. Anytime you have cotangents and negative secant square and negative CSC of x, COT of x. Now you have to memorize this. If you don't memorize this, you pretty much have a hard time. So I will remember this right side, and I'm not going to repeat myself how to remember that one. Logan will help you if you don't know, because I don't think that's appropriate for me to say. Well, again, biology teacher can say. Why does math teacher cannot say?
Aren't you the one who told it to us?
Huh?
Aren't you the one who told it to us?
said it.
Huh?
I forgot exactly what it was. But I mean,
Yeah, you're the one who told us
We
it.
need a reminder.
Yeah, we need to
Well,
remind.
no, I don't need to remind. Logan's going to remind to you.
Yeah, look, what is it?
If you have if you have a tan, you have sex twice. And if you have sex, you have a sexy tan.
I don't know.
What about sign? What about sign?
Sign we don't have come up anything, so we're waiting for you to come up. So anyway, it's from my students, not from me. I don't have like this kind of mindset, so not like you guys.
His mindset's more in the oscillating slaps.
Oscillating slap. Kind of deserve that. Okay, so also you have to understand a lot of things that derivative cosine. Do you guys understand why derivative tangent is equal to secant squared? Do you guys understand that?
No.
So, yeah, you don't have to memorize actually. So, d to the dx, hey. D to the dx of tan of x. I don't need to pass this. Everything okay?
Yeah.
Okay, derivative tangent of x, basically just derivative of sine of x over cosine of x. And if you follow the quotient rule, then it's going to give you the same evaluation. So, low, d high, which is cosine of x. Does that make sense? Minus high, d low, which is negative sine of x, over cosine square of x. And then that's equal to cosine square of x plus sine square of x over cosine square of x.
Which is just equal to 1.
Which is equal to 1 over cosine square. That's why I want you to memorize also identities, because those identities come back to help you. So if you really forgot how to do it, you still can derive from out of thin air. So it's not something that is come out like I'm normally just like I want you to memorize it. It's actually from quotient rule. But how do I take a derivative of secant of x? Well, how do I use the same idea and do derivative of secant of x? 1 over cosine, good job. D to the dx of 1 over cosine of x. And it's going to be low, d high, minus high, d low, over low, which is cosine square of x. So it's going to be sine of x over cosine square of x.
Then you factor out one of the cosines.
Yeah, and then you change that sine of x over cosine of x times 1 over cosine of x. So that's going to be secant of x, tan of x. There you go. That's your sexy 10.
Could you go back into the rules, please?
So they didn't come out from thin air. They come out from somewhere. Okay, they come out from somewhere. So derivative of the trig function is done.
Could you zoom in on the rule?
So derivative of sine of x, there was a proof for that, but I don't want to do it. It's sum and difference formula, and you have to use definition derivative. It's just disgusting, and I don't want to get involved. But yeah, it can proving that sine of x equal to cosine of x, and you have to use a couple different type of trig limits to do it. I can take a picture, send it to you, but I'm not going to do it because I don't have that time. Question about this. Today I'm going to show you something very interesting. And some of you guys got 4s and 5s, probably remember how to do this type of question. Maybe Robert, maybe Eva, and Hernandez and Connor. You guys might know, might remember how to do this. So what if I have a list of questions? And we have this question, 2 parentheses of x plus h to 2/3 minus 2x to the 2/3 over h. So we have a question like this. And with the limit h approach 0. And this is on AP exam a lot, so you guys remember what to do. It should be done in 15 seconds. If you spend more than 15 seconds, you're a sucker for this problem. I know. Gabby already know. Nicole already know. Okay. Luke already know. So 4 people already know. Eva, do you remember?
No, not really.
Robert, do you remember? Connor, do you remember? Maybe. So we got 3 people knows right now, which is Nicole, Luke, and Gabby. You think you know? Okay, Logan, what do you think the answer is?
I would say it does not exist.
No. Then you don't know it. Gabby, what do you think?
Are you just taking the derivative of 2x to the 2/3 power?
Do you guys remember this?
Is it L'Hopital?
No, it's nothing to do with L'Hopital.
It's the definition
It's a definition
of
of derivative. Remember definition of derivative is f prime of x equal to limit h approach 0 of f of x plus h minus f of x over h. Do you remember this? But if you look at this, right, you look at this, actually, I won't go by this. I actually go by this better because this one lie. This one lie sometimes. I will show you how they lie. Okay, I'll show you how they lie. They look at this one. I always look at this one. Think about which function I plug in, x plus h. It's going to be 2x plus h to the 2/3. Think that way. It'll be much better. So you can figure out that this is definition of derivative. I plug in x plus h on one of them, and I use a function on the other one. Does that make sense? And then I can say, well, that's x plus h. This one is on that exam. It's on my test. It's on anybody's test. So please know it. Write down. It's like really important. This type of question, like Luke got it right away. Gabby got it right away. Nicole got it right away. There's a reason because they see what's going on. So I hear f of x is equal to 2x to the 2/3, because there's no way I can break down the x plus h to the 2/3 power. There's no way I can distribute that unless you want to kill a puppy. Okay, so this is the part that you cannot distribute in because it's to a 2/3 power. So f of x equal to 2/3, then what are you going to do? We're looking for f prime of x. If this one's a definition of derivative, then all we got to do is take a derivative of this, and that's equal to 2 times 2/3 times x to the negative 1/3. So it'll be 4/3 x to the negative 1/3. It's pattern-based analyzation, right? You can analyze this much easier. So on AP exam, they don't want you to spend time doing this. They want you to think. They say, okay, what does this mean? On SAT, they don't want you to spend 5 minutes on a problem. They want you to spend 15 seconds on a problem. This is how you're going to do it. In AP exam, they're not going to say, use definition of derivative to prove the derivative is this. Not going to. UCF test? Maybe. University of Pittsburgh test? Maybe. They probably did that. No? Do they do multiple choice or do they do free response?
Some of it was free response, but it was you never had to like show your work.
Oh, really?
It's just like,
Yeah, that's a lot easier. So I guess you have the computer program. You had to do a lot of computer program, answering computer questions like ISL.
yeah, it was like,
Yeah, those are annoying. But those are, you just have to figure out a pattern, then you can be fine. Okay. So does that make sense? So why did I say this part lied to you? This part can really lie to you. Why? Because they can do, oh no, why this part lied to you? Don't think about functions 2x to the 2/3, because I can very easily make something that I can lie to you, which is limit h approach 0 of, I don't know, 3 x plus h square minus 4 times x plus h, right? And minus 3x squared plus 4x over h. So that's why I never look at this, because this is tricky. I will look at always, this is not something I will look at, because you thought the function is a 3x squared plus 4x, but it's actually 3x squared minus 4x. Do you guys see that? So if you look at this, right, you want to think about which function you can plug in x plus h. Right? The function has to be 3x squared minus 4x, not 3x squared plus 4x. Because what happens if you factor out a negative sign here, this one's going to change in sign. If I put a parenthesis over there. Does that make sense? So those are something that you had to be very, very cautious, and you had to be able to do this. Okay. So those are the definition derivative connections. It can be involved with chain rule now. Can be involved with the trig now. Can involve with anything. So later on we can get to ask question much more higher tier. Something I forgot to mention for those of AB student and for BC as well. So derivative, we talk about a triangle of differentiable, right? We talk about a big triangle. Did we talk about a triangle? I saw it on Margot's notes.
yeah.
We did that, right? The continuity and differentiable. So let's just review a little bit. Sorry, this is the I don't know if I use that word right. Is a paradigm? Or I don't know. I don't know my English anyway. Limit exists, right? Is limit x approach to a from the left of f of x equal to limit x approach to a from the right of f of x. In middle part is gonna be, is continuous, right? So continuous is f of a has defined, because that's on the last test. 2, limit x approach to a of f of x has to exist, which is the bottom layer. The bottom layer is basically says that. 3 just says limit x approach to a of f of x has to equal to f of a. So 1 and 2 have to equal to each other. Now differentiable, I don't have, is limits x approach to a from the left of f prime of x is equal to limit x approach to a from the right of f of x. Today you're going to have some homework involved with this part. In order differentiable, left derivative has to equal to right derivative. The slope has to be completely the same from left to right. You cannot have a sharp turn. Okay? So those are the things that you have to know for the AP exam goes. AP exam go, you have to know the definition of derivative connections. So definition of derivative connections. Lastly, when is not differentiable? Can you name 3 situations not differentiable? So when is not differentiable? Well, the first situation is what? Yes.
There's like a corner in the function.
Corner.
Oscillating.
What is it?
Oscillating.
Oscillating? I don't know. That one is kind of big. Depends. Huh? Discontinuity. Well, so something's not continuous, right? So not continuous. And we're also going to talk about, and this could be vertical asymptote, right? Or hole, right? Or jump, right? It's a lot of situation. 2, it's a corner. You guys call it corner. I didn't call it corner. I called it sharp turn. I call it sharp turn because left does not equal to right. Right? 3rd, it's actually a very, very common one. But also, they always test on AP exam is this one. Vertical tangent. Vertical tangent occur in x to the 1/3 power. It looks like this. If I would draw a tangent right here, it's going to be vertical. Slope is going to be undefined. Sometimes vertical tangent can be a cusp. A cusp can be like this. X to the even over odd power. So x to the 2/3 power is called even over odd. Is going to create something called a cusp. So a cusp is also a vertical tangent. A sharp turn, kind of like mix between. So a sharp turn usually is absolute value, like absolute value x. So those are the things not differentiable. You have to understand all this concept and connect all the concept. Conceptually, you have to understand. Am I going too fast?
Could you zoom in on the whatever you said at the top of the triangle?
Is differentiable is limit x approach to a from the left, a to the right of f prime of x. They have to equal each other. Sorry, I missed the f prime of x. Thank you. They're both f prime of x. F prime of x from the left have to equal to f prime of x from the right. Today you're gonna have homework question. You're gonna have 2 questions about this. You have to take you not only have to make them continuous like the previous test, you have to make the derivative have to equal from the left equal to right as well, in order to make it complete and smooth. We're gonna show you how that works tomorrow. Yes, Nicole.
When you say the cusp example wouldn't be differentiable, that would be like at the origin it wouldn't be differentiable, or?
At this case, it's at origin is not differentiable. Yes, only at this point.
Okay.
It's only where the vertical tangent occur. So vertical tangent come in very, very matter a lot. They ask that a lot, which is usually take the derivative of the denominator equal to 0 because that's where its vertical tangent occurs. Numerator equal to 0 is a horizontal tangent. Denominator equal to 0 is a vertical tangent. And that usually you have to do that on the AP exam. Am I going too fast? Okay. So last thing is chain rule trig. This one's fun. This one's fun because this one is like this. So how do I take a derivative of this? How do I take a derivative of this?
Then we have two different functions, or four different functions.
You would do,
Give up.
Give up.
you would do the,
Who said you give up? No, don't give up.
you do the exponent first, so it would be.
I'm going to show you a trick to do this kind of question. You create a lot of bubbles. I rewrite this. To the fourth power. I rewrite this. Does that make sense? Does that make sense first? So this is a function within a function within a function within a function. So this is chain rule to the extreme. So what happened is, first function you're gonna see is x to the fourth, because something to the fourth power. But what do you plug in x to the fourth? You plug in sine to the tangent of 3x, right? And you plug in tangent of 3x, right? And then that's pretty much 1, 2, 3, 4 bubbles. So you start with the outer bubble, because chain rule you're going to do from the outermost and you go to our inside. It's like peeling onions. Every time you peel, it's going to take out one layer. So f prime x, I'm going to peel out the first one. So it's going to be 4 of sine to the third of tangent of 3x. To the third power, but I write down third inside. Is that okay? Then I'm going to leave inside alone. Now I'm going to take a derivative of the second layer. What is the second layer? The sine of tangent 3x, right? So it's going to be cosine of tangent of 3x. Does that make sense? Then times, you keep on going, times the third bubble, which is what? Secant square of 3x, and times 3, and that's my derivative. Does that make sense or no? Okay, so you're gonna do one. How much time I have? 2 minutes, that's good. That's good. Tangent to the fourth sine of square root of x. Be careful with this one. And you have to know all your trig limit on this type of questions. Today you're responsible for chain rule. You're also responsible for horizontal tangent of trig. So that means you had to go back and review all your trig stuff. Okay, I'm gonna do it here. So it'll be tangent of sine of square root of x. I rewrite it to the fourth power. So that's gonna be first layer. First layer is right here. The second layer is right here. The third layer is right here. The fourth layer is right here. So before tangent of 3 sine of square root of x times secant square of sine of square root of x times cosine of square root of x times 1/2 x to the negative 1/2.